Hi guys, welcome to Tech Stack. So today we are going to discuss about monitoring Spring Boot applications on production environment. We need to take care of multiple things to monitor Spring Boot applications on prod. We'll see them step by step. First thing is application health and metrics monitoring. It is achieved by actuator endpoints. We can configure it by adding actuator dependency in project's form file. Actuator exposes internal metrics and health information of application. The key endpoints provided by actuator are actuator health. It is used to check application and dependency health. Next endpoint actuator provides is the metrics used to check JVM, CPU usage, memory details and GC pauses. Another one is like actuator ENV. Environment configuration validation is done by this endpoint. We have actuator info. It gives us the build and version info. Why we need actuator? To detect crashes, memory leaks and slow threads early. It is used by Kubernetes load balancers and monitoring tools. Second thing is metrics monitoring. For that we use Prometheus plus Grafana for visualization. So first thing is, what is Prometheus? Prometheus is an open source metrics monitoring and alerting system that is widely used to observe applications, servers, containers and cloud infrastructure. It scrapes metrics. In Prometheus, scraping simply means Prometheus sends an HTTP request to an application's metrics endpoint, reads the metrics and stores them as a time series data. Step by step, what happens during a scraping? First, Prometheus waits for the configured interval and then sends an HTTP GET request. Application returns metrics text. Prometheus parses the metrics, stores them in its time series database. How often does scraping happen? So it is configured in prometheus.yml file. For example, here if suppose scrap interval we kept is 15 seconds. So every 15 seconds Prometheus scrapes the target. Each scrape is a snapshot at that moment. What endpoints are scraped by Prometheus? Default it scrapes metrics endpoint. For a Spring Boot actuator Prometheus it scrapes. Now we will see Grafana. So Grafana is visualization tool which visualizes the data provided by Prometheus. Grafana visualizes Prometheus metrics by querying them using PromQL and displaying the results as a dashboards, charts and alerts for easy monitoring and analysis. What you monitor? So it monitors request count and latency, error rates, JVM heap and GC pauses, thread pool saturation, DB connection pool usage. For example, alert if error rate is greater than 2% for 5 minutes. Now the third point is centralized logging, which is mandatory in production. For centralized logging, we configure ELK stack. The ELK stack is a centralized logging solution used to collect, store, search and visualize logs from distributed systems. The ELK stands for Elasticsearch, which stores logs. Logstash, it parses logs. Kibana, search and dashboards, basically provides the visualization platform for the logs. First, we will see what is Elasticsearch. It stores and indexes log data. It is distributed search and analytics engine which stores logs as a JSON documents. All the log data is stored and indexed for a quick retrieval. Why we need Elasticsearch? It is extremely fast search built for massive log and event data. It provides near real-time analytics and it is also distributed and fault tolerant. Now we'll see Logstash. It is a data processing pipeline. Logstash collects logs, parses and enriches them and sends structured data to Elasticsearch. Why we need Logstash? Converts unstructured logs to the structured JSON data so that it will be stored in a Elasticsearch. It adds the metadata related details, for example host, environment, trace id to the logs. It is a central place for log transformation, keeps apps lightweight, no parsing logic, so that we don't need to handle the parsing part in the application itself. It is separate from the application logic. Now we'll see Kibana. It is visualization and exploration UI for logs. Kibana is used to search, filter out and visualize logs stored in a Elasticsearch to investigate issues and understand system behavior. So basically we need Kibana to centralize log analysis, fast search and filtering, debug microservices easily, visual dashboards, incident and RCA support. So that we just if suppose we wanted to find out the root cause analysis of particular issue, so we can just directly query the logs in the Kibana and able to find out the root cause of the issue. Now we'll see distributed tracing. It is very much important in case of microservice based application. Distributed tracing lets you follow a single request end to end across multiple microservices and see where time is spent and where failures occur. We can achieve it by using a Sleuth and Zipkin. Sleuth and Zipkin or Jagger enables distributed tracing by tracking a single request across microservices, showing latency at each step and identifying slow APIs or database calls. It tracks one request across many services by adding a trace ID. Spring Cloud Sleuth automatically adds a trace ID and span ID to every request. The same trace ID travels with the request across microservices. So result of it is like one complete request flow end to end with the same trace ID. See where latency is added. Each service records how long it takes to process the request. These timings are stored as spans. Zipkin or Jagger displays a timeline. By using we can say it as a waterfall view. Identify slow APIs or DB calls. Tracing captures HTTP calls, database queries, messaging calls. By using Kafka or RabbitMQ, slow spans are highlighted in the UI. You can drill down to method name, SQL query and error message. Now we will see infrastructure and container monitoring. Kubernetes Cloud Monitoring focuses on the health and performance of the platform running your applications, not just the application code. Infrastructure monitoring is equally important as monitoring application code. So we will see how what exactly we need to monitor. The first thing is like pod, CPU and memory. It shows how much CPU and RAM each pod is using. It helps detect memory leaks, CPU throttling and under over provisionings. For example, pod using 95% of memory, likely to be object out of memory killed. Second thing is like restart counts. We need to monitor number of times a pod restarted. High restart count indicates application crashes, out of memory errors, failed health checks. Key signal for unstable deployments. Next, like we need to monitor node health, status of Kubernetes worker nodes, monitor CPU pressure, disk pressure, network issues, node availability. Node failure can impact multiple pods at once. Next, we can see like autoscaling behavior, how horizontal pod autoscaler reacts to load. Things we need to monitor in this case is like when pod scale up, down, whether scaling is fast enough, if limits are too strict or too low. Common setups to achieve infra monitoring are Kubernetes plus Prometheus, cloud native tools like CloudWatch or Azure Monitor. Now we'll see next point, alerting and incident response. Alerting detects system issues automatically while incident response ensures fast investigation, resolution and recovery of the issues. Alert manager PagerDuty. It alerts on high error rate, service down, memory leak symptoms, Kafka lag, queue backlog. Good alerts include they should be actionable with minimal noise, linked to dashboards. We'll see big picture architecture of the alerting system. It is like in a SpringBoot application, it is already exposing the metrics. which is scraped by Prometheus as we see earlier. Prometheus evaluates alert rules. Alert manager sends alerts to Slack, email, pager duty as per we configure. Grafana dashboard visualizes the alerts. So we can say like alerts trigger automatically, not manually. Next thing we will see is security and audit monitoring. It focuses on detecting security threats, policy violations, and suspicious behavior by continuously analyzing logs, metrics, and events. First thing is auth failures. It includes repeated logging failures, invalid tokens, expired credentials, possible brute force attacks. For example, more than 10 failed logins from same IP in 5 minutes. Second thing is rate limit breaches. It includes clients exceeding allowed request rate, indicates bots, scrapers, DOS attempts. For example, API key exceeded 1000 requests per minute. Third thing is suspicious request patterns. It includes requests from unusual geographies, abnormal request bursts, invalid payloads, malformed headers. For example, same endpoint hit with random payloads every second. Fourth thing is like API abuse detection. It includes excessive retries, unauthorized endpoints access, token misuse. We already cover all the points to monitor the Spring Boot applications on production environment. If you guys want any of it to be discussed in detail and configured it in the actual project architecture, let me know in the comment section and I will make the videos on that topic separately. Thank you all. Good day.